Alright, so in this video I'm going to talk about the wide range of sensors that VEX provides, some ways that you can use them, how to initialize them in your program, and I'm just going to walk through kind of each one and its basics. Obviously, these sensors have a lot of depth in them, and I will not be able to explain everything about them in this video. So I do recommend that if you're interested in using one of these, you go to the VEXcode Doxygen and search the sensor in here. So, for example, I'll search the Inertial Sensor, and then I can click on this. And here I can see the all the functions that I can use with this. I can calibrate it, I can set the heading, I can get the angle, the pitch, yaw, orientation. So going here and searching up the sensor will show you how you can use it, what functions you can use with it. So that way you can get a better understanding of whether it would be useful to you or not. But with that out of the way, let's go to each of these sensors and go through them. So the first sensor we're going to take a look at isn't really a sensor per se. It's the V5 smart motor that you guys use in the build, and these have built-in shaft encoders as well as a temperature sensor and a voltage sensor, I guess. I'm not sure. That's probably just built in, but I'm not sure if they need a dedicated sensor for that. But this shaft encoder you probably already used, because these left drive, start rotate to, and reset rotation are all using the encoder. And the temperature sensors are actually super useful for knowing like what temperature your motor's at, and if it's overheating, or if it's fine, or if it's thermal throttling. So that's extremely useful, and I'll teach you how to make a simple check for that in a little bit. So with that being said, some of the commands you can use this with are over here in the command reference, and they're also on the Doxygen as well. So here we can get the current of the motor with this command. We can get we can know its position. We can know if it's spinning. We can know its efficiency with the current and the encoder. And we can know its power, and we can know its temperature over here. These are all very useful stuff for debugging, or if you want to rotate to a certain position, you can use these commands to check for those stuff. So if we wanted to make, for example, a command that checks for the temperature, you could do void temp check, and then take, let's see, arm motors temperature in Celsius, and then we could assign this to a value. So we could do double arm temp. We could do arm temp equals the arm motor's temperature, and then we could have an output for that. We could do it in the terminal if you know how to do that. But something that is super useful for debugging, which I'm also going to try to show in this video, is printing to the brain screen, and also to the controller screen. So if you didn't know before, you can actually print to the brain screen, because if here, let me click on one of these. I believe you might have, or not. Okay, let's do this real quick. Alrighty, yeah, here we go. So this right here, it's a little bit hard to see, but the brain has about 12 rows and 40 some columns. So these all represent a space that a character will take up. So you can print characters to these rows. So for example, I will mock up something right now. Alright, so I've mocked something up right here real quick, and unfortunately they made printing to the brain screen a little bit complicated, so you may have to play around with this a little bit. But essentially what I have right here is a command that clears the screen of the brain at the start, and then it sets its cursor to column 1. So it sets its cursor right there to column 1, 1. And then it'll print this string right here. And then this last part right here is, that last part right there is the troublemaker. Because this is essentially telling the code to print whatever value is here as a floating point number with a two decimal places. Now this can be kind of difficult because sometimes the syntax is a little bit weird and it doesn't quite want to work. So, you might have to play around with like taking off percent signs, or like adding a 0 in here to make it display properly. And you can look stuff up on like Stack Overflow and stuff like that to figure out how it exactly works. But this is essentially how you print debugging stuff to the brain. And if you wanted this to run as, say, a task, like we learned about in the last video, right here, so that it can run while you're doing other stuff, you can just make this an integer, and then add a return statement at the end, and then we can change this to temps, and that to temp check, and then this will basically start the temperature check task, and we can actually put a loop in here. Do while true, which is just an infinite loop. And then put a bracket at the end. And what is gonna happen here is that it'll start this task and then keep going with the rest of the autonomous, and then this will just loop where it takes the temperature of the arm motor and then prints it to the brain screen. Now we don't need this to update like all the time, so to save resources, we'll probably add a bit of a wait to it, like maybe 5 seconds, so that way we aren't wasting the computer's processing power by running infinite loops. So I would definitely recommend mocking up something like this for all of your motors, because a big thing that can cause deviation between autonomous runs or driver runs is when your motors get too hot because you've been running them for a while, and then they have to thermal throttle. And I believe this happens at This happens at around 55 degrees is when your motors start to thermal throttle. So it's always a good idea if they're getting close to that number, or if they're above it already, to turn off the bot and cool it down before you start testing stuff, because it will skew your results. So that is pretty much the important stuff about the motors. Of course, you can do pretty much anything with this brain screen print statement. You can print out the values of like any of the other sensors we're about to talk about. You can print out the values of the encoders using this motor position statement right here. So this is extremely powerful right there when you're trying to figure out what went wrong. So anyway, that's enough for the motor sensors right now, and we're going to move on to the next one. So the next sensor is the rotation sensor, and this sensor is a little bit obsolete actually, now that the smart motors have their own encoders inside of them. So this is basically the same thing that's in this motor, except outside and not included with any motor. So if you wanted to have like a free floating wheel, this might be helpful because it can see the rotation of that free floating wheel without it having to be attached to a motor. But most of the times you'll have those wheels attached to a motor, so this one is usually not too useful. But just like with the motor encoders, you would use this one right here, that position or rotation. But instead of motor, it would just be the name that you made the shaft encoder. If you want more functions, again, they'll be on the Doxygen. I'll link it below. This is a very helpful tool, so I definitely recommend looking it up here if you don't know what the commands are. So that's about it for the rotation sensor. So the next sensor on the list is the V5 Optical Sensor, and this one's kind of an interesting one. I'm gonna be honest, I haven't really worked with this one before, so I'm not very familiar with how it works. But this is essentially a combination of a light, color, proximity, and gesture sensor. So this can be helpful if you want to distinguish between different field elements that are different colors, so you know like what to pick up and what to leave, or stuff like light values, so you know if like a flap is like covering something, for example. So this one can be used for a bunch of different stuff. Apparently it can also be used for gestures as well, which I'm not sure how that works quite well. But if we look in the Doxygen, if we go to Optical and take a look at some of the commands here, it looks like you can grab the brightness or the color. So if we wanted to add one inside of here, we would just go to Optical, add it in the port, and then we could reference it saying like Optical 5 dots brightness, and we can attach that to a variable. So if we declare one like double bright, and then set that equal to it, we could store the brightness into a variable. So that's one of the ways you could use this function. But yeah, this is one I'm not too familiar with, so you might have to experiment with it as well. This sensor is probably one of my favorites. It is the VEXcode V5 distance sensor. And what this does is it can measure the distance via a laser between 200 millimeters and 2,000 millimeters. So this is especially useful if you want an accurate, if you want a more accurate autonomous, because it can account for error and just stop whenever it's at a certain distance. So this one can be used in a similar way to the other ones. If you look down here, let's add one real quick. Distance sensor. If we look in the command reference, you can see the distance right here. So you can see if an object's detected, the object distance, and you can do inches, centimeters, millimeters, object size too, and object velocity as well. So we can see if we're standing still, or if we are moving but we're measuring something that's standing still, we can detect how fast we are going, or how fast the object's moving. And these all return variables, or all return a number that you can put into a variable to use in like a while statement, to say like while the distance is less than, say, like 10 inches, keep moving forward. So that's just a kind of a combination of some of the stuff we've done here with like the checks for controller position. We could just modify that and use that as a check for the distance. So those are quite useful as well. Probably one of the more useful sensors out of VEX's kit. Now this is probably my favorite sensor out of all of the ones I've shown so far, and out of all the ones I will show, the Inertial Sensor. Now this one can be super powerful if you use it right. It can sense how fast what direction you're turning, how fast it's turning, and at what angle. So it measures the rate of rotation around 3 axes. So it's a combination of an accelerometer and a gyroscope. So if we want to use these, what we got to do is, just like the other ones, we can add it as a sensor. But another useful thing that you can use, and this is something that I haven't really told you about, just because it's a little bit finicky, is using drivetrains. So these things are kind of interesting because they basically take motors, inertial sensors, and combine them into one thing that you can use. The problem with setting these up is that you cannot use the drivetrain and the individual motors at the same time. So you can come into conflict with that a lot of the times. So that's why I don't really recommend using them. But if you're not very familiar with how the inertial sensor works and you just want a simple way to use it, you can make a drivetrain. So I'm just going to make an example one, ports 15 and 16, and then we're going to use an inertial sensor at 17. And then we're going to have 4 inches of diameter, 1-to-1 gear ratio, and that'll be done. And what we can do here is do drivetrain dot turn, and then we can do turn for angle. So we can turn right and at, so let's say 90 degrees. And then what this is going to do is turn it right at 90 degrees. We can also specify the speed as well. Do 200 RPM. Or I believe this goes afterwards, actually. My bad. Yeah, so we can specify the speed as well. And this basically takes all of the inertial sensor work out for you. But again, I don't really recommend it because it can interfere with stuff you already have, like left drive and right drive, because you'll have to take out these motors and replace. You'll have to take them out in the robot configuration and replace it with the motors you set up in here for starting the drivetrain. So it'll probably break a lot of your old code. So instead, what I would recommend is making a code that checks for it more manually, and I'll show that to you right now. Alright, so this might seem a little bit daunting at first, but this is really pretty simple. So basically what I'm saying here is we're making a void function with turn type direction, which basically means you can input left or right for this value. It's not too important for what we're doing here. We're inputting speed, and we're inputting the angle, and we're inputting the timeout. So if the direction is right, is what we're checking for here, we're doing a while loop. And we're saying while the rotation of the inertial sensor is less than the angle we want to be at, keep turning right. And we have a little wait millisecond here, so we don't waste resources. And then once that's done, once we reach the angle, it'll break right here. If we're turning left, it's the same thing, but the angle will go down. So we're saying while the angle is that the inertial sensor is greater than the angle we want to be at, we're going to turn left. So that's essentially how you would make a basic turning thing, or turning code. Obviously, you would replace drivetrain with your motors and everything, but this is pretty much it. Keep in mind that because your turn has velocity, it may not stop at the correct angle. So you may want to have the angle be outputted to the brain screen, like I showed you with the arm motor. So that way you can know what the angle is, and you can either subtract the angle. You can take less of the angle to compensate, or you can lower the speed so you have less velocity at the end. but you may have to do one of those depending on how heavy your bot is and the speed you're turning at, all of those factors. This also works with the distance sensor with a little bit of tweaking. If you just change the angle with distance and change turn type to just a regular direction type, it will basically be what the distance sensor will be. So you can use this for that as well. The next sensor we're going to talk about is the bumper switch. Now this is a pretty simple sensor, but it's pretty useful actually. You can use this to tell when you're up against a wall, when you're up against a tower, like even when you're up against a game element, because it can detect low force actuation. So these are pretty useful as well. When you use them inside of the code, you can just add a device, and these ones are a 3-wire device. So these will go into the ports on the side of your brain. So they look like this, and they'll be like small flat ports that you'll plug them into. So these, all you'll have to do when you're adding them is go into 3-wire, and then you'll have access to the bumper switch. So you'll just choose which port it's in. We'll do just bumper A for now. You have a bumper. And then you can go into the command reference and then look at bumpers. So since bumper is a pretty simple sensor, it only really has like one command that you can use, and it's a bumper.pressing. So these are essentially the same things we were using for the controller. So the controller button pressing, except it's a bumper. So these will return a Boolean value, which is a true or false statement, and you can put these into a variable by making the variable a Boolean variable. So by doing that, you can just say bool pressed, or we'll do bool bumper pressed, and then you can just say bumper A dot pressing, and then set that equal to bumper pressed. And now this bumper pressed will have the value of this right here. So you can use that in like an if-else statement, where it's just saying like while true, so while you're checking for it, if it's pressing, you can run some code. If it's not pressing, you can run some other code. So yeah, that's the bumper sensor. It's pretty simple, but quite useful. Along with the bumper sensor, there's the limit switch. It's pretty much the exact same thing code-wise. It's just like in a different form factor, pretty much. This can be useful if you just want the bumper to actuate in one direction. So you can prevent it from actuating in a certain direction. So it's pretty much just the bumper switch in a different form factor, like I said. And the last sensor I'm just going to touch on briefly, because this one could probably use an entire video on its own, is the VEXvision sensor. And this sensor I would describe as jack of all trades, master of none, because it has a bunch of different uses you could use it for, but it does all of those pretty okay. Like, if you want to find the color of like an object, you can use the vision sensor, but it's probably easier to use an optical sensor. If you want to find like movement, you can also use the optical sensor or the distance sensor. So it's yeah, it's okay. It is more helpful if you want to like see an actual video feed, because you are able to connect a screen to it and just see what your robot is seeing. So it is useful for that. It is also useful for if you want to track down something. You can use like the where it is on the output of the vision sensor, and then adjust your robot to pick it up. But that is quite complex, and if I do go over the vision sensor, it will probably be in its own video. So I'm just going to leave this at that. But that is pretty much all of the sensors that you will need to know about. Obviously, there are a couple more, but those are from V4, which is the last version of VEX Robotics, and they're a bit outdated. I'll just say that. But if you want to learn how to use any of these sensors, or you forgot like what the commands were, you can go to the VEXcode Doxygen, or add it into your robot configuration and then go into the command reference, and they will usually be under sensing, so you can find them here. But yeah, other than that, that's all I got for sensors today. If you have any questions, just make sure to leave them in the comments below, or ask one of us in the Robotics Club. We do have a Discord as well. I'll leave the link in the description. You can join that and ask questions there as well. Good luck.